Computer here. All right, let's hope I'm doing everything all right. Find out later. All right, so 10 problems coming your way. And I think it's 40 new problems altogether. Let's get you so it's level. And let's see if I can get this done in the next 20 minutes or so. I hope so. Not a great lengthy lecture here, but some new material. And old material is not going anywhere. You still got to learn it. So sketching 3 times the absolute value of x minus 4 plus 8. That's not new. Here's the graph. I'm not going to speak on that. We have a picture. The first new problem is writing this function as a piecewise function. And I hope that you can see that there's a couple of branches to this absolute value, and don't be fooled by these arrows. When you read a graph, you move your finger along the curve from left to right, and my finger is decreasing and then increasing. Now, where does it change? It changes at x equals 4. All right. Well, what happens at x equals 4? Well, if you put a number bigger than 4 into x minus 4, you get a positive. And if you put a number less than x less than 4, you get a negative. But the absolute value is going to do what? It's just going to measure distance, and distance is always positive. So that's why it's changing signs here. We're changing directions, I should say. So what do we have? We have a shared coordinate, 4, 8. And we have a decreasing function and then an increasing. Now, how do you get from 20 to 8? Go down 12. And that took 4 units of change. So we're reading this graph from left to right. So from left to right, how do you get from 8 to 20? You go up 12. 4 to 8, 4 units of change. Well, looks like on the left, we're going down at 3 to 1. And on the right, we're going up at 3 to 1. Those are the branches. So over here, we can write, knowing that we're decreasing then increasing, minus 3, x minus 4 plus 8. And we're looking at that when we are looking to this side of the number 4, which is when x is less than 4. And I think this is just the equation of a line. The only thing is it's defined for x is greater than or equal to 4. And it doesn't matter which one we put the equal sign. It could have been up above, could be below, but generally speaking, the increasing side is when x's are bigger than. And so you want to learn how to do that. And it'll take a little bit of practice, but I hope that makes some sense. So we're going to use, we've already used a number line to think about this a little bit. And now we're going to solve for 38. Let me come back to the picture. And I want you to estimate first. Okay, so we're going to estimate. So how do we do that? How do we solve for 38? 38's up here. Well, the question is, how do you get from 8 to 38? You got to go up 30 units. So your estimate should be pretty good, because every time you change by one number, I think I have it over here, right? 4 gets us 8, 5 gets us 11, 6 gets us 14, 3 gets us 11, 2 gets us 14. Very similar to the quadratic, except that we have a real constant rate of change here, right? We're going up 3 here. And if we look backwards, we're going up. So if we look forwards, we're going down at 3 to 1, which we discussed over here a minute ago. All right, so we need 30 units of change from 8 to 38, and we're changing every change in x of 1. Our y values are changing by 3. So I think that's 10 jumps of 3. So we're 10 units away from the number 4. We should be -6, and we should be 14 as answers. That's my estimate, which seems like it's not an estimate. Seems like it's exact. But let's find out if that's right by doing what? How are we going to solve these equations? Well, there's different methods. And what I've landed on is not the quickest necessarily, although actually it might be with a little shortcut, but we're not going to take the shortcuts right now. We're just going to use the branches. We're going to take the decreasing side and the increasing side. We're going to say, when does the decreasing side equal 38? We'll do that because of space here. And then we'll do the increasing. We'll just change that. And I think we're gonna take away 8. I think we can see -10 jumps. It's gonna take us up to 38 from the tabular side of things. Where was I? Okay, so the addition's gone, the multiplication. So I think we're gonna add 4, -10 plus 4, and I think, what we said a while ago is helping. So let's put that answer right here. -6 gets us 38. Now we're gonna do the increasing side. There it is, piecewise. And it's gonna be very similar. The first step is the same. We're gonna get a sign change here. All right, so subtract 8, 30, divided by 3 is +10. And now I'm gonna do +10 plus 4, which is 14, which is what we thought it would be. So there's our numbers that make it equal to 38. But the next question is, what happens if we want to be bigger than 38? Well, I think all we have to do is to look at where we were, the critical numbers. We found the critical numbers in this equation, what works, what makes it equal. Well, I know one thing, equal isn't the same as greater than, so these numbers don't work anymore. But we have 3 intervals, A, B, and C. Well, why don't we just pick a number and see if it's true or false? And that's why I called it a truthful number line. I already know which ones are true and which ones are false, but you're going to have to look at the patterns over time and allow your brain to see patterns, which is a big part of learning to think mathematically. All right, I know it's going to be true, but let's check it with a number that's bigger than 14. You can pick 15 or 16. I like to try 1,000,000. 3 times 1,000,000, remember it's positive, plus 8. I got a figure, that's true. And I got a feeling this is false without looking at it. But let's find out. Let's pick a number between -6 and 14 and 0, you say, yes. Let's put 0 in. 3 times the absolute value of 0 minus 4 plus 8. Let's see what that equals. That's equal to 3 times 4 plus 8, which is equal to 20. And 20 is not bigger than 38. No, it's not. False. I got a feeling this is going to be true because of the symmetry. Let's put a -1,000,000 in. Oh, that's right. The absolute value of -1,000,000 is 1,000,000. And we're right back to 3,000,008. And I do believe that's bigger than 38. True. Now the question is, how do we write it? Well, in your 7th grade or whatever pre-algebra classes, you probably talked about conjunctions and disjunctions, ands and ors. All right, so we have x is less than -6, or you can do x is greater than 14. That's true. The only problem is if you said and, pretty hard to be a number less than -6 and bigger than 14. Pretty hard to be 2 places at the same time. I've tried, not easy. Yeah, so we use what's called interval notation. And interval notation takes us to where? -infinity, right? All the way back to -6. Union, also our answers could start at 14 and go to infinity. What I've basically done is a number line, -6, number line. That's what that means. Now, I put or equal to, the original question was or equal to, then we simply color these in, and the parentheses becomes a bracket. And I just planted some seeds here. That pretty much takes care of the absolute value problems that we're going to be doing, diving in a little deeper than where we have been thus far halfway through this semester. Now, the beautiful thing about number lines is they help us quickly with a variety of problems, like domain, for instance. And I know at this stage you all have a great definition for domain in the old noggins. Oh, you want me to mention what domain is? What numbers can I use? What numbers? And it's usually easiest to find out what numbers you can use by finding which ones you can't. Right? But just identify the critical numbers. Let's identify 4 as being critical. And let's identify 6 as being critical. And I'm going to circle that because you know what? I can't really use that number. But it still breaks this up into intervals. Okay, so let's find out if I can use a number bigger than 4. A million, you say. A million minus 4 over a million minus 6. If you did that on a calculator, would you get a number for an answer? Of course, you would have to say yes. So let's call it true. Or let's use yes, you can use. Yes, you can use these numbers. Can I use the number 4? Well, the lights went out on that question. Well, let's hope you can still see. Let's see. If I put the number 4 in, I get 4 minus 4 over 4 minus 6. Yeah, I think that's equal to 0. Calculator's working just fine. So yes, you can use the number 4. Can I use a number less than 4? Now, why did I pick 6 and put it to the left of 4? Why didn't you tell me I did something stupid like that? Talking away. Well, 6 is over here. Can't believe I did that. Anyway, not going to make a new video because students are coming in about 10 minutes, and I want to get this done. All right, so 6 minus 6. Oh, that's a problem. That's undefined. All right, so I got to circle that and say I can't use that. All right, so can I use a number bigger than 6? We just already found out I can't use anything less than 4, right? I mean, that's imaginary. You would never graph an imaginary on Descartes' real number line coordinate system. So no, I can't use these. And I think we already checked 4 with a number like, well, let's use 5. All right, let's see. So this was a yes over here. Butcher in this problem. Square root of 1 over 5 minus 6 negative 1. I think that gives us an answer. So yes. So I can't use the number 6. It's undefined. I can't use anything less than 4 because that gives me an imaginary. So I guess I got to write this in interval notation. So no, I can't use the number 4. Can't use it. Oh, no, I said we could use it, right? So we can use the number 4. You can tell I'm trying to hurry this video. I can use the number 4. I can go all the way up to 6. But I can't use the number 6. It's undefined. So I'll pick up again and head to infinity. And that's the answer to number 5 on the worksheet that we're presenting to you. And hope that that makes a little sense. All right. Now, we've got an inequality here. You might want to guess, how are we going to solve that? Well, with a sign chart, for starters. All right, so what do I see? I see critical number at 0. Critical number at 2, and a critical number at 6. I guess I got to come up with this. Critical number at 6. Heading to infinity, negative infinity. Let's try some numbers, see if they work. I don't think these numbers work. No, because if you put those numbers in, we studied that, then it would equal 0. And I don't want to equal 0. I want something else. I want something bigger than 0. So why don't we try this interval? You say, well, what do you mean by try that interval? I say, yeah, good question. Pick a number. I like a million. So I like a million squared times a million times another million, just estimating here. Is that going to be bigger than 0? I think so, yes. Why don't I say true? For sign charts, we'll use true. Of course, you know that's false. Of course, you know this is true and that's true, right? You know the pattern already. But you say you don't know the pattern? Oh, so you want to keep an eye on the pattern. I got to tell you something. It's got something to do with the exponents. And I drew a dot at 0, and I drew dashes here. I think we're going to get sign changes here. Yep, odd exponents. I think we're going to get sign changes. I think if I put a number like 7 and 5, I'm going to get a different sign here. But 7 and 5 don't affect this, and 7 and 5 don't affect that. So I've got a nice little sign chart here. So if I put a million in, we already saw that. Let's put a number like 4 in here. 4 minus 6 is a negative. 4 minus 2 is a positive. And 4 squared is a positive. And that's going to be greater than 0. Definitely not Negative is not bigger than 0. Oh, I wrote false. But I think a number between 0 and 2 is going to get us a sign change. So let's pick a number like 1. 1 minus 6. Well, that's still negative. 1 minus 2. Oh, that changes this parentheses to a negative, but doesn't change this one. I don't care what I put in there. I'm going to get a positive. Unless I square 0, I'm going to get a positive. So that's true. And I don't think we're going to get a sign change here. It's going to stay true. So that's what we're going to practice. And for the sake of those of you who will be taking calculus some point in time, we get away from sign charts and we just start graphing. And one thing I know, that the bigger the number I put in after 6, the bigger the product. So I know my product is going from here, from 0. Whoa, it's going up. It's polynomial. And I think the graph is going to look like this, and there's no sign change here. So that's what your graph's going to look like. So when are we bigger than 0? Well, I think all of these x's, I hope you can see, are getting y values that are, all those y values here, they're positive. Whoa, you know what? These are negative y values, and they're not bigger than 0. Everywhere else is. So if I saw this, I would say, negative infinity works. I'm getting, big time positive numbers, bigger than I can imagine. 0 doesn't work. And 2 doesn't work, but 0 to 2 does. And negative 6 doesn't work. But I'm going to positive infinity. And so there's your interval notation. It's going to take a while to learn how to do that. Got to start the conversation somewhere. All right, so here we go. We got ourselves one more problem. We got one more problem here, and then we'll the door, because I think folks want to come in and start a test. All right, so we got ourselves oh yeah, we can see that right there. Got ourselves a fraction here. I'm going to put the light on. The youngsters doing their tests. Put the light on. All right, so when is this bigger than 0? I wonder what technique we're going to use to solve this. Oh, you say, why not a sign chart? Put the critical numbers, and that's to the first power. So I'm going to get a sign change there. This is to the first power. I'm going to get a sign change at -4. I got a feeling if I try some numbers, I'm going to find out. Let's make this or equal to 0. Let's make it or equal to 0 this time. So if I put 5 in, I get 0 over 9. Is that equal to 0? Well, 9 times 0 is 0, so I guess it is. Yeah, so 5 works. And of course, we don't have to spend any time with -4. We know that that doesn't work. That's undefined. So that leaves us intervals A, B, and C. And let's just check them out real quick by putting a number bigger than 5 in there. 1,000,000, you say? Yes. And that gets us 1,000,000, 2,000,000 over 1,000,000 roughly. Yeah, that's positive. So if I put 1,000,000 in, I get a positive divided by a positive, and that is bigger than or equal to 0. So yes, true. And if I put a number in between -4 and 5, I'm going to get false. Why am I going to get false? Because if I put 0 in here, that becomes a negative. It doesn't affect this one. And I know I'm going to get true again. If I pick a -1,000,000, -1,000,000 means that that's negative, and that's negative. The negative divided by a negative is a positive. So this is definitely true. So what do I have? My answer, negative infinity to, can't use -4. Can't use it, so it's a parentheses. Union, I can use 5, bracket can be used to infinity. So we put some thoughts in your head. Now let's look at this function a little more carefully. Let's actually sketch it. We already have a little information at our fingertips, which we'll probably come back to. But fractions, so you're looking at a fraction. Fractions can be big, they can be small, they can be 0, they can be positive, they can be negative, they can be undefined. So what jumps off the page at us? Well, the two critical numbers, 5, we just said 5 gets you 0, and -4 is undefined. So let's do that. That's an x equals. All right, so where's the y-axis? Is a little off center left. So there's our y-axis. It's really easy to get a y-intercept. Plug in 0 and you get what, -2.5? So -2.5, 0 gets us -10 fourths or -5 halves. I already have two values. Hey, I wonder where this is going. Looks like it's going up. Oh, you say it's going up to y=2, you'd be right. Yeah, because the bigger the number, like 2 billion minus 10 over 1 billion, I'll put a 1 there. Let's get a fancy 1, plus 4. You know, when you're talking about billions, I don't think you really care too much about 4 and -10. Remember, I'm just planting seeds. It's gonna take you a while to learn how to do these. A lot of classes skip them now because students have so much trouble with them. So give yourself a smile and a relaxed attitude here. It's going to take you a while. It's going to take you some days of practice to get the, what do we do to get what we get? Right now, I can see y=2. And what we get is some interesting behavior here. L'Hopital, I. That's what this graph's going to look like. Okay, and some of the things to help us are, what's the limit of this function as we go to infinity? As we go to infinity, I'm telling you, you're going to 2 because you got to think about that. You got to think about putting a big number in. And where are we going as we go to, did I change this? I think I changed this on the sheet. I may be doing a different problem than what's on the sheet. X plus 4, okay, no. All right, so negative, I think I'm gonna change it. -4 from the right. So what is happening, limit is really about the y values. What are the y values doing as I come in from above, right? Here's -4 here, right? And so a number like -3 is bigger, and that's what this plus sign is indicating, that in a table of values, what's happening? All right, well, let's put a number like -3.99 in here. All right, that's going to give us 0.01, yes? 0.01. That's a small number. And it's going to fit into, you know, we can just use the number -4 here. Something approximately around -18. Well, that's going to multiply this number by 100. You know, when you divide by a fraction, 1/100th, you multiply by the reciprocal. This is going to fit into the number 100 times. It's going to fit into this -1800 times. All right, and I think every time we throw another decimal in there, we get an answer that's 10 times bigger. So that's asymptotic behavior. And what happens if I put in a 4.001, a -4.001? We get a sign change. So instead of going to negative infinity, we're now going to head to positive. All right, and what's the x-intercept? The x-intercept of a fraction is coming from the numerator. 0 in the denominator is undefined. So that's what allowed us to say 5 gets you 0. Now, what do I see? I see a positive, I see a negative, I see a positive. Remember that problem we did over here? True, false, true, when it's bigger than 0. All right, so these are the types of problems we're going to look at in more detail, more depth, but we're not going to be doing that until we cover it coming back from break. We've got 40 problems. There's the first 10. All right, so sorry for the mix up over there. Trying to get this done too quickly. And you know me, I'm making a mistake on every one of these videos. Just got to deal with it. All right. See you soon.